Alright, so now what we want to do is talk about how we can actually look at a quadratic equation and tell what type of solution that we have before we even start to do any work. Okay, and so the key to knowing this is to look at what's called a discriminant. And so the discriminant is the expression that's under the radical of the quadratic formula. So I'm rewriting the quadratic formula here. And so that expression b squared minus 4ac is called the discriminant. And so we know, based upon a discriminant, that tells us or discriminates on how the answers look. And so we have three conditions here. If the discriminant is positive, then we know that the result is two distinct solutions. Okay? And so what that looks like is, let's say, x is equal to -5, x is equal to 1/4. So we have two distinct places where that particular quadratic function will cross or touch the x-axis. In the case of b squared minus 4ac equaling 0, this is what we call the case when we have a double root. And so a double root just basically means that we only have one solution. So let's say if we had x equals -5 as a solution. And so that means that the graph of our function, if we were actually looking at it, would look something like this. And so with the parabola only touching the x-axis once, like that, we call that the double root. In the case of b squared minus 4ac being less than 0, this is a situation where we have complex conjugate solutions. Okay? And so what this communicates to us in terms of a graph is that our particular function does not cross or touch the x-axis at any time. So if we were looking at, let's say, the graph of some function that looked like this, it kind of went up like that. If we were to actually solve that algebraically, we would see that the solutions would be complex, meaning that for this particular function, there is no real number that allows us to be able to cross or touch the x-axis there. Okay? So basically what we want to do is whenever we see our quadratic equation, we want to extract the function from there, figure out what a, b, and c are, plug it into our discriminant, and then see if the discriminant is positive, negative, or 0. And so then from that, we'll be able to figure out how many solutions it has. And just to repeat it here, if the equation has repeated real solutions, that's what a double root is, then the discriminant would be 0. If it has two unequal real solutions, or what I call two distinct solutions, then that would be the case of the discriminant being positive. And if the equation has two complex solutions, then that's the case of the discriminant being negative. So we'll go ahead and clear this and try some of these out. Alright, so come here and we know that for this particular one, we have a is equal to 5, b is equal to -8, and c is equal to 6. So if we plug that into our discriminant here, we'll see that our b is -8, so we do that squared minus 4ac. And so we have 64, and so this would be 4 times 5 is 20, 20 times 6 is minus 120. So we have 64 minus 120. We know that's going to be something that is negative. So in this case, we know that we're going to have two complex conjugate solutions here. Okay? Alright, so we'll go ahead and move on to number 10 now. So for number 10, we'll go ahead and try the same thing. So clear this, do the same type thing, see what we end up with. Okay? So for this one, of course, our A is 4, our B is a -2, our C is 3. And so do our discriminant. B in this case is just a -2, so we square that, and then C. And so now, for this particular case, we see that we got 4 minus, and then this is 12 times 4, which is -48. So again, it's negative. So we end up with two complex solutions that are not real. Okay. So we'll go ahead and move on to 11. We'll repeat the process. Right. So for this one, one of the things I would recommend to keep from having to do very large numbers here is, in this case, since we have this particular equation here, let's see if we can factor anything out. So we know all these have a factor of 4. So if we factor out 4, that would be 9x squared minus 12x plus 4 equals 0. And so if we divide both sides by 4, we just end up with this. So we'll just use our A is 9, our B is a -12, and our C is 4. And we'll go ahead now and evaluate our discriminant. So when you do that, our B is a -12, square that, minus 4AC. Okay. So now this is 144, and had a pretty good streak there with 4s, but it's over now. So we got 144, and so we have here, what is it? 4 times 9 is 36, and then 36 times 4, that would be another 24, 12, 14, so 144. So in this case, we see that they're both equal, so that means that our result here ends up being 0. So since our result is 0, then we know that that's the case where we have repeated solutions. Okay. All right, so this concludes on how we look at the discriminant of the quadratic form to be able to surmise what our solutions look like before doing anything.